Okay, so we want to take a look at this question here, and it says, two uniform smooth spheres, A and B, of equal radii, each have mass m. The two spheres are each moving with speed u on a horizontal surface when they collide. Immediately before the collision, A's direction of motion makes an angle alpha with the line of centers, and B's direction of motion makes an angle beta with the line of centers, as seen on the diagram. The coefficient of restitution between the spheres is a third, and 2 cos beta is equal to cos alpha. Okay, so on part A, they say, show that the direction of motion of A after the collision is perpendicular to the line of centers. Okay, so we are going to consider what we have here to be before collision, as the question says. So this is before collision. But let's also analyze what is going to happen after collision. All right. So after collision here. All right. So after collision, we're going to have the two spheres. Okay. Right here. Here is the second sphere. All right. So this is what we have. And I'm going to extend the line of centers like this. So this is what we have. This is still particle A, and this is B. And before collision, the components, the component of U is going to be here. This is the component that is perpendicular to the line of centers, and it is U sine alpha. Okay, so let me move this up a little. All right, and the component that is in the line of centers is this component here, which is U cos alpha. For B, the component that is in the line of centers, okay, that is perpendicular to the line of centers, is U sine beta. And the one that is in the line of centers will be going in this direction. So that's U cos beta. All right. Now, after collision, for particle A, the component of the speed that is perpendicular to the line of centers will still be U sine alpha. And the one which is in the line of centers, we'll call it VA. For particle B, the component that is perpendicular to the line of centers is U sine beta, and the one that is in the line of centers is VB. All right. So we're going to say here, along the line of centers, we will consider the principle of conservation of momentum, where we are saying that the momentum before collision is equal to the momentum after collision. All right. So for the momentum before collision in the line of centers, we will be having m of u cos alpha. Okay. So m u cos alpha. And we'll also be having m of u cos beta. But since it's going in an opposite direction, it'll be minus. So we'll say here minus m u cos beta. And this is equal to, for the momentum after collision in the line of centers, we'll be having mva plus mvb. All right. So mva plus mvb. All right. Now we can rearrange this. Okay. We can rearrange what we have so that we'll be having va plus vb is equal to, and here we will be having, we can factor out u, so that's u of cos alpha minus cos beta. And I'm going to call this equation 1. Next, we're going to look at the concept of Newton's law of restitution. Okay, so the coefficient of restitution. Okay, and for this, we will say VB minus VA Okay, that's the relative speed of separation. VB minus VA is equal to E, which in this case is a third. Okay, that's the coefficient of restitution. So that's a third of, and that's going to be U cos alpha minus U cos beta. So that'll be a plus. So U cos alpha plus U cos beta. So that's what we'll be having. All right. And now we can simplify this to VB minus VA is equal to a third. I'll factor out U. So it's a third of U of cos alpha plus cos beta. So let's call this equation 2. All right. So I'm going to say here to eliminate B, we'll say equation 1 minus equation 2. And why are we attempting to eliminate B? Here the question is saying we should show that the direction of motion of A after the collision is perpendicular to the line of centers. So we're talking about the motion of A after collision. So that's why we have to eliminate the motion of B, which is VB after collision. So equation 1 minus equation 2 will give us VA minus VA is 2VA being equal to, and we will be having here U of cos alpha minus cos beta minus a third U of cos alpha plus cos beta. Okay, so that's going to be 2VA being equal to, and here I'm going to factor out U. So we'll be having cos alpha minus cos beta minus a third cos alpha minus a third cos beta. All right. So that's 2VA being equal to U of, and we're going to say here cos alpha minus a third cos alpha, which is 2/3 cos alpha, and then minus cos beta minus a third cos beta is minus 4/3 cos beta. Okay, so this is what we have. Now, the question is saying, okay, we've been told some pretty useful information here where they said that 2 of cos beta is equal to cos alpha. All right. So before we can make use of that, let's just multiply both sides by 3. All right. And if we do, we'll be having 6VA is equal to, I'll also expand brackets at the same time. So that's 2U cos alpha minus 4U cos beta. Okay. And I'll say here, since we've been told that 2 cos beta is cos alpha, 2 cos beta is equal to cos alpha, then it means that 6VA will be equal to 2U cos alpha minus 2U of 2 cos beta. So this is equivalent to this, right? So 6VA is equal to 2U cos alpha minus, and for 2 cos beta, we use cos alpha. So it's 2U cos alpha. So technically here on the right side, we're getting 0. So 6VA is equal to 0 and VA is equal to 0. All right, so we're getting VA to be 0. And here they are saying we should show that the direction of motion of A is perpendicular to the line of centers. So if it is perpendicular to the line of centers, it means that the horizontal component is 0 and the horizontal component is VA. So this is the proof. So I'll say here, therefore shown. And that's how we do it for this particular question. Let's move on to the next question, part B. It says, the total kinetic energy of the spheres after the collision is 3/4 mu squared. Find the value of alpha. Okay. All right. So here we're talking about total final kinetic energy. Okay, that's the total energy of the spheres after the collision. So I'll call that final kinetic energy. And for that, we know that after collision, we have two particles here. So for A, we have been told, all right, we actually have shown on part A that the direction of motion of A is perpendicular to the line of centers, and that VA is 0. So VA, this is equal to 0. So the particle will be going completely upwards. So the speed will be u sine alpha. Okay, so the kinetic energy will therefore be half m of u sine alpha squared. Okay, so u sine alpha squared, and that's going to be plus. Now we go to particle B. So for particle B, we want the resultant of these two components. That's the speed. Okay, so it's the resultant. We get that by the square root of VB squared plus u sine beta squared. Okay, so I'll say here it's plus half m of the square root of VB squared plus u sine beta squared O squared. So what we have here is half of m u, actually u squared sine squared alpha plus half m of VB squared plus u squared sine squared beta. All right. So that's what we technically have. And what I'm going to do here is I'm going to factor out half m. So we'll be having u squared sine squared alpha plus VB squared plus u squared sine squared beta. Okay. Now for VB, if we go back to any one of the equations, let's take, for example, equation 1. All right. So we want VB. So taking from equation 1, okay, we have this equation. That's equation 1. But remember, we proved that VA is 0. So therefore, VB is equal to U of cos alpha minus cos beta. All right. So we're going to substitute that into what we have already, into this thing here. Right. So that's going to be half m of u squared sine squared alpha. But for VB squared, it means I'm going to square this. So it's going to be plus u squared of, and if I square this bracket, we get cos squared alpha minus 2 cos alpha cos beta plus cos squared beta. And we're going to say plus this. That's plus u squared sine squared beta. Okay. So all this is under a bracket, right? So this is going to be half m u squared of sine squared alpha plus cos squared alpha minus 2 cos alpha cos beta plus here that's going to be cos squared beta plus sine squared beta. All right. So that's half mu squared of. Now this 2 give us 1. And this 2 give us 1. So 1 plus 1 is 2. So it's 2 minus 2 cos alpha cos beta that we will be having. But remember, we have been told that 2 cos beta is cos alpha. Okay, so we're going to make use of that. So I'll put it here. So 2 cos beta is equal to cos alpha, which therefore means that we'll be having half mu squared of 2 minus, and for 2 cos beta, we'll put cos alpha, so it becomes cos squared alpha. All right. So we are being told that the total kinetic energy after collision is 3/4 mu squared. So we're going to say, therefore, half mu squared of 2 minus cos squared alpha should therefore be equal to 3/4 mu squared. All right. And automatically the mu squares will cancel out, and we are left with half of this. All right. I'll just multiply both sides by 4. All right. And we'll be having on the left side 2 of 2 minus cos squared alpha is equal to 3. All right. And from here, that's 4 minus 2 cos squared alpha is equal to 3. So that's 2 cos squared alpha is equal to 1. And cos squared alpha is equal to a half. All right. So cos alpha is equal to plus or minus of 1 over root 2. And here, the fundamental angle here for arc cos 1 over root 2 is 45 degrees. And that's actually the value of alpha we need. So alpha is 45 degrees. Okay. So the question was saying we should find the value of alpha. So this here is the value of alpha. And that's how we do it here.